effectively, yeah, can I? So effectively, that that helps you. So the target enclave asks the SGX hardware to produce its own report key. Now it can verify the MAC after reconstruction of the MAC key. The caller enclave calls the SGX hardware to extract the report key for the target enclave and then MAC the stuff, right? So note that only SGX hardware in the target enclave can obtain the target enclave's report key. So it's a good hardware isolation principle in place. Now if the target enclave is the quoting enclave, then the quoting enclave can extract the attestation key and then produce an attestation signature in place of the MAC. And now we have remote attestation. So only a proper quoting enclave could have obtained the attestation key, and a client who verifies the signature, this particular signature, with the attestation key, right, verifies it with the verification key belonging to the attestation key. Yeah.
So the report key actually contains the identity of the target enclave as well?
Yeah, let's have a look. That must be one of the future slides. So.
But this report key was just for the verification of report, right?
So the caller enclave is calling this particular e-report construct. What the hardware is doing, it takes this platform-specific info and the target enclave's measurement, and with the fuse seal key, and gets the report key. That's this guy. This is the report key. The report key is now mixed with the identity of the caller enclave into a MAC key. And the MAC key is used to produce a MAC over the whole report. So that means that the MAC key binds the caller enclave's identity, the processor's identity, and the target enclave's identity all together. So now let's have a look at the next slide, one of the next slides, this one, where the target enclave is going to verify. The target enclave is calling eCAT and effectively the SGX hardware takes the fuse seal key, takes the identity of the target enclave. Oh, that is a mistake here. And then, yeah, okay, so here we should not mix up some things, but here the caller enclave of the eCAT key functionality is in our example the target enclave, right? So the target enclave identity is now mixed up. It gets the report key out of the eCAT key as a result. It has received the report, so it can now extract this identity, create the MAC key, then produces a known copy of the MAC, and then check whether they're equal, and then you can accept or not accept. That's how that works.
But there can be so many clouds asking for eCAT key, right? But only one would get accepted.
Every enclave who asks for an eCAT key in its code, then the SGX hardware takes that enclave's identity, mixes it up with the seal key to derive a report key. But I cannot ask, say, for your report key, because I do not have your identity. My measurement is different from yours. So I know that the report key is only going to be visible to that enclave software for which that report key is destined. So it's a bit confusing to call this a caller enclave in our example, but this means the one who calls the eCAT key in this particular case, right? So that's how you should think of that. So, yeah, it's pretty cool. Yeah. So this is maybe the picture that is the best for that. All right, so this is our review session. So I hoped that I have answered at least the main confusion around attestation. And it's getting close to 5 now. So any other questions though before we get kicked out? Okay, so let's stop here then.